This is Algebra 2 with Trig, working on Review C. Here we're going to talk about what is the law of sines. Well, law of sines is a method that we can use to solve for missing sides and missing angles of a triangle. It does not have to necessarily be a right triangle. And that's our typical formula for law of sines. And we can use it for angle, angle, side, angle, and SSA, side, side, angle. Those are our main ways that we end up using law of sines. Law of cosines, got three different versions of law of cosines. And it can be used primarily when law of sines doesn't work, when you don't have two bits of information from the same letter, when you don't have the angle and its opposite side. That's law of sines, the angle and the opposite side. For law of cosines, you don't have to have that situation. It's typically a little bit more challenging to calculate through, a little bit more algebra. Therefore, if law of sines was available, we would definitely use that instead. And we use this for side angle side situations and also side 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 situations. Okay, solve the triangle. So here we have a triangle. We notice that it's an acute triangle. The opposite side is shorter. So this is A. This would be considered C. We know that A is less than C. So now we gotta determine what the height is. What is the height here? So one thing we can do is sine of 28 would equal this height over 12. And if you multiply by that 12, we can determine what the height is. Remember, you need to be in degree mode to figure this out. So the height is 5.6. So here we have 5.6. So that's our height. So 7 is definitely going to reach the ground. So this triangle is possible. We needed to verify that. So in this situation, we're actually going to have two triangles, because it's less than 12, it's more than 5.7, so we could swing out here or we could swing in. We're going to calculate this value. We're going to first start out with the law of sines. So we have 7 over the sine of 28 equals 12 over sine of C. We multiply up. We divide by 7. So we get 12 sine of 28 divided by 7. We get 0.848. .8048. So law of sines sine inverse, as a law of sines. Sine inverse is going to give us a 53-degree angle. So that's our angle right here. 53.59. So that would be the measurement of angle C. So now we can find the measurement of angle B by saying 180 minus the 28 that we already know, minus the 53.59 that we just calculated, and that gives us 98.41. So that's our angle B. And then to find our last side, that would be side B over the sine of 98.41 is going to equal 7 over the sine of 28. 7 times the sine of 98.41 divided by sine of 28 gives us 1475. So this B length is 1475. So those are the three values for that original equation, triangle. So now what we're looking at is if we have a triangle that swings in, this side's going to swing in, that's going to be supplementary to this one. So we still have our 28, we still have our 12, we still have our 7. This angle is going to be 180 minus the 53, as we've talked about in our previous lessons. So 180 minus 53.59 gives us 126.41, and that is angle C right there. So now to find the measurement of angle B, that's going to be 180 minus 28 minus 126.41. That gives us 25. 25.59. So this is 25.59. When we use this as an obtuse angle, that angle B is going to get much smaller than 98. Because it swings in, it makes that angle smaller. So all we don't know is this side B. That's B over the sine of 25.59. Make sure I had those right numbers. We still have 7 over the sine of 28. Still can do our law of sines. So we'll cross multiply one direction. 7 sine of 59, actually 25.59. And divide that by sine of 28. So that side length is going to be 6.44. And we found all the missing sides. That was a double triangle. That's like the hardest thing we got on this review. That was a biggie. Okay, now we have an obtuse angle. We have an acute angle. Call that the acute angle. Side C would have to be the one in between that. So this is an angle side angle situation. Okay, we talked about we could use law of sines for an angle side angle, but we don't seem to have a side and the opposite angle value. We can get this by subtracting from 180. So that gives us a 52-degree angle. That's the measurement of angle C. Now we have all three sides, or all three angles. So now we're going to calculate for whichever one you want. Let's go for B. So B over the sine of B is going to equal C over the sine of C. So we don't know what B is, so the sine of 112 equals 15 over the sine of 52. I'm going to cross multiply one direction. If I'm going too fast, you can always pause the video, rewind the video, listen to it again until you understand. Ask me questions in class. So that would be our length of B, 1765. That seems kind of funny. Just kind of checking my work. I would expect it to be a little bit larger than that if that's 52. That looks accurate to me at the moment. So now we'll see if this one makes sense. We're going to calculate the missing side, so side A. So side A over the sine of 16, that's a smaller angle. And we're going to use the 2 that we started with. 15 and the sine of 52. So 15 sine of 16 divided by the sine of 52. It gives us 5.25. A equals 5.25. So we calculated these. The largest angle gives us the longest side. The next largest angle gives us the next largest side. And a much smaller angle is going to give us a much smaller side. And this triangle would only have one possible triangle. You don't have to worry about the double triangle we did before. It's not a side-side angle situation. So here we have a 57-degree angle. The side opposite of that is 8, and the additional side is 12. So this here is a side-side angle. We've got to watch out to see what's happening with this. Is it actually touching? Is it going to make two triangles? What's going to happen? So we're going to calculate our height. So 12 sine of 57, as we learned before, is the height. 12 times the sine of 57 is the height, so that's 10.0. So the height here is 10.0. That means the height is too much, and this 8 actually would never reach the ground. It would just sit there and swing at a 57-degree angle, making this point right there. Length of 12 makes an 8 never touch the ground. So no triangle. This is a 68-degree angle, a little bit steeper. So that's B, we'll call that 68. We'll call A up there at 42. I'm just trying to approximately draw these things in here. 42. So that's going to make this C. Side A. Oh, side A is here. Okay, let me redraw this one just because it's... Oh, this is actually angle side, so we don't have to worry about how we draw it so much. Alright, no need to redo it. So I can find out the measurement of angle C by subtracting 68 and 42 from 180. We get 70. So that's the measurement of angle C. And now we're going to use law of sines again. So we didn't practice any law of cosines. You might want to look at law of cosines. There is some law of cosines. So we're going to use 15 over the sine of 42 equals C over the sine of 70. 15 sine of 70 cross multiply divided by sine of 42. That gives us 2107. So C would be 2107. And then we have to find the last side, so we've got to do it one more time. So B over the sine of 68 is going to be 15 over the sine of 42. And that's 20.78. So the largest angle, 70, has 21. The medium one, which is super close to that, has 20. And then one considerably smaller is smaller. Alright, finding the angles, or areas. So in this triangle, just so we can visually see it, we have an 81-degree angle. We don't have side B, but we have side A, and we have side C. So this is a side angle side situation. So in that, we're going to use our formulas right here. So we're going to say the area is half 18 times 15 times the sine of 81. Half times 18 times 15 times the sine of 81. So the area is going to equal 133.34 square units. This one is side, side, side. So if you think about a side, side, side triangle, you would have one side be 18, another side be 24, another side be 30. I don't have any of the angles. I can't use this formula. I don't have an angle. Now, could I use law of cosines to find it? Sure. And then you can use that to calculate the area. Or we can come down and use this other, where we use the semi-perimeter, which is half of 30 plus 18 plus 24. 30 plus 18 plus 24, and we divide that by 2, and we get 36 as our semi-perimeter. So then our area is going to be 36, and 36 minus 30 times 36 minus 18, 36 minus 24. So we're doing the square root. Here I want to determine what the middle number, the inside number is, the radicand. 36 minus 30, 36 minus 18, and 36 minus 24. So that we're doing the area of 46656. The square root of that answer gives us exactly, that's a fun one, exactly 216. So the area is 216 units squared. So the one thing this review did not focus much on was law of sines. That is true. So you want to look at law of sines. You're going to use that when you don't have 2 bits of information. Kind of like here, if we were going to solve for an angle, we would need to use law of cosines. So if we want to solve for the largest side, you always solve for the largest side, which would largest angle. If we were doing that for this problem, we would need to do c squared equals a squared plus b squared minus 2ab cosine of c. So you would put in your 30. Okay, let me do this for you. Just want to be sure that we get some representation of what we're doing with law of cosines. Okay, maybe you would pause the video and try it out yourself. We're going to find the angle value of this triangle that we had in number 8. So we plug in our numbers. Okay, so we're going to take our 30 squared minus our 18 squared minus our 24 squared. And then this whole thing is going to be on the bottom. It's going to be divided. So you can calculate it there. What you don't want to do is calculate all of this. You can't calculate all that because some of it's multiplying, some of it's not. So you have to subtract over your 18 and your 24. So I'm going to do 30 squared minus 18 squared minus 24 squared. And that gives us, interesting, that gives us 0. Okay, so now it doesn't matter what we have on the bottom, times 18 times 24, because that's 0. And cosine inverse of 0 so if our like adjacent over hypotenuse was 0, what angle is 0? It's going to be 90 degrees. So this is actually a right triangle. So maybe we're not so surprised it came out such a perfect number. That helps support that. Okay, if this is a right triangle, we should be able to test the theory of a squared plus b squared equals c squared, and that's what the 0 showed us. And that is. So anyway, this would be a 90-degree angle. I showed you how to use law of cosines. We solved for the angle. That's the trickier part to do. Okay, now we're going to flip over and we're going to talk about graphing sine and cosine. So the first thing we want to do is calculate the period. So the period equals 2 pi divided by b. That's 2 pi divided by our b value's 2. So that's giving us a period of pi. That means the whole graph is going to go through its cycle until it reaches that x value of pi. The increment is calculated by the period divided by 4. So that's pi divided by 4. So that means we're going to have pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Since we have a 3, we're going to be up at 3. This is cosine, so we start at a maximum, then we go to 0, then we go to our minimum, then we go to our 0, then we go up to our maximum. And there's our graph. We're doing our increments by pi over 4. Our amplitude, of course, from our midline down or our midline up is a length of 3. It's always a positive number. And our range is going from -3 to 3. Now we're going to try to graph this crazy thing. Okay. So we're going to figure out what the period is. It has to do with B. So if B is 1/8, the period is going to be 2 pi divided by 1/8. That's going to be 16 pi. So that's the period, 16 pi. So our increment's going to be divide that by 4. So we're going to have 4 pi, 8 pi, 12 pi, and 16 pi. Pretty big steps. The graph that we're going to do right now is just -2 sine of x, -2 sine of 1/8 x. Because the 1/8 makes our scale. Now we're going to do sine, which starts at 0 and it goes down to 2. It looks like we have room to count by 2s. So we go from 0 to our minimum because it's negative, back to 0, to a maximum, and back to 0. So there's our graph. This is y equals -2 sine of 1/8 x. So next we're going to translate it 2 pi and then up 1. Well, that's kind of funny, since this big step is 4 pi, 2 pi is just going to be half of that. So we're going to go over 2 pi and up 1, go over 2 pi and up 1, 2 pi and up 1, 2 pi and up 1, 2 pi and up 1. I like to use a different color when I'm making a second graph on it. There it is. We have a midline. That midline has all of these points here at y equals 1. This graph is that long one. Our transformation, we have a reflection over x-axis. We have a vertical stretch by factor of 2. That's the A value. We have a horizontal stretch by factor of 1/8. Now, 1/8 we typically think is shrinking, but the 1/8 in our equation is actually stretching it out. We notice that by dividing by 1/8, because period is 2 pi divided by b. The 1/8 is what made our period 16. It actually stretched it. And then our translation. We're going to translate right 2 pi units and up 1 unit. Okay. We look here. We are looking for the amplitude. That looks like it's 1, 2. The amplitude would be 2. 1, 2, negative 1, negative 2. So the amplitude is 2. The range goes from negative 2 to 2. And the period goes all the way to 2 pi over 3. Now, if we were going to write an equation of this, I'm going to focus on the most easiest equation we can do, and that would be this one right here. Focusing on that as a cosine graph that is not reflected, is not translated. So our amplitude is 2 cosine. Now the question is, what is B? What makes our B? This is a tricky one. So remember that period equals 2 pi divided by B. We know the period is 2 pi divided by 3. So if I cross multiply, I get 2 pi b equals 6 pi, and divide by the 2 pi, I get b equals 3. There is no h value. There's no translation. It has a maximum on the y-axis, so you don't have to focus on a translation. And there's no translation up or down, since we're going, the amplitude is the same from the x-axis in both directions. So that would be it. Let's take a look at this one. This one is not touching the y-axis very cleanly. So I'm going to look at starting way over here and going all the way. This looks like it's 7 pi over 2 and another pi over 2. So that's 8 pi over 2. So our period equals 8 pi over 2, which is known as 4 pi. So if we wanted to know our b value, period equals 2 pi divided by b. The period is 4 pi. So I'm going to multiply up and divide down. So b is going to be 2 pi over 4 pi. And that's going to be 1/2, which makes sense, because the half stretches it out, and it's stretching it out twice as much. That's what 2 pi becomes 4 pi. So what I see in terms of an equation, I see a sine graph that is upside down. So we have a negative sine graph. It does look like it's coming down to 1, which is half of the 2, so that's not moving. So there's no amplitude other than the 1. Sine, we decided that the b value was 1/2. Now we have to use parentheses because we see that it's being translated to the left, pi over 2, but it is not going up or down any. That midline is right on the x-axis. So our transformation reflection over x-axis. It has a horizontal stretch by factor of a half. Since the b value is less than 1, it's going to be a stretch. If the b value was greater than 1, it would be a shrink. You see that it goes through the whole period in less than 2 pi. This is doing the whole period in way over 2 pi. There is no vertical stretch. There's no a value other than 1. And translated left pi over 2. There we have it. Good luck.